Our next section from the chapter, application of derivatives, is the concept of local maxima and local minima. Now I am going to discuss about local maxima and local minima of a function. What is that concept? Consider the graph of a function y is equal to f of x. This is a portion of the graph of y is equal to f of x. We are considering a portion of that graph. Look here, when we are considering this region, here we have on x-axis the point C1. Therefore, on the graph C1, f of C1 is this point. And if you are considering this region for a point, for a very small value h greater than 0, if you are marking in the graph the values C1 minus h and C1 plus h, in this region we can say that in the region, in the interval C1 minus h, C1 plus h, f of C1 is the greater value, that is f of C1 is greater than all f of x for all x belongs to this interval C1 minus h, C1 plus h. Look here, when we are considering the interval C1 minus h, C1 plus h, in this interval f of C1 is the maximum value attained by our function. Therefore, we are calling f of C1 as the local maximum value of our function f of x. And C1 is known as the point of local maxima. That is, clearly local maxima means at a particular locality which is the maximum. That is known as local maxima. In this region, that is in this interval C1 minus h, C1 plus h, f of C1 is greater than all f of x for all x belongs to this interval C1 minus h, C1 plus h. Therefore, we are calling f of C1 as the local maximum value of f of x. Then, considering this point C2, look the point C2, and we can see that in the region, similarly just like C1 minus h, C1 plus h, if you are considering the interval C2 minus h and C2 plus h, in this interval, we can see that f of C2 is the minimum value attained by the function. In this interval, look, in this interval, f of C2 is the least value attained by our function. Therefore, we can call f of C2 as the local minimum value attained by the function y is equal to f of x. Just if you can wait, just looking the graph, we can again see that f of C3 is another local maximum value and f of C4 is another local minimum value. Similarly, f of C5 is another local maximum value. Therefore, what's the definition for local maximum and local minimum value? At a particular locality, which is the maximum value attained by a function, that value is known as local maximum value. And which is the minimum value attained by the function at a particular locality, that is known as the local minimum value. Here f of C1 is the local, f of C1 is the local maximum value. F of C1 is the local maximum value. Therefore, we are calling C1 as the point of local maxima. Point of local maxima. Similarly, C3 is another point of local maxima and f of C3 is another local maximum value. C5 is another point of local maxima and f of C5 is the local maximum value. Then coming to C2, f of C2 is the local minimum value. we are calling C2, the C2 as the point of local minima. Clear for you? Now we can go to the definition in your text. Look, let f be a real valued function and let C be an interior point in the domain of f. Then C is called a point of local maxima if there is an h greater than 0 such that f of c greater than or equal to f of x for all x in c minus h, c plus h. The value f of c is called the local maximum value of f. C, and it can be equal also, and C is called a point of local minima if there is an h greater than 0 such that f of c less than or equal to f of x for all x in c minus h, c plus h. The value f of c is called the local minimum value of f. You just write up to here as the definition of local maxima and local minima in your notebook. Okay? We are going to find local maxima and local minima without the help of graph. Look, we can easily identify that C1 is a point of local maxima, C3 is a point of local maxima, C2 is a point of local minima, C4 is another point of local minimum. The general characteristics of these points are, they are critical points. They are critical points of the function. If this is the y, if this is the graph of y is equal to f of x, we can easily see that these points are the critical points of our slope of the tangent is equal to 0. These are critical points of our function f of x. Therefore, the general characteristics of these points are, these are our critical points. Now look, C1 is a point of local maxima. Therefore, if you are taking a point less than C1, slightly less than C1, look the shape of the graph. The graph is increasing. Therefore, in terms of derivative, we can say that f dash x is greater than 0 for all C1, slightly less than for all values slightly less than C1. But when you are taking a point greater than C1, and remember slightly greater than C1, look the shape of the graph. Graph is decreasing. Graph is decreasing. Therefore, in terms of derivative, we can say that f dash x is less than 0. Therefore, we can use this thing as a method for checking whether our critical point is a point of local maxima or local minima. The method is like this. First, you have to find out the critical points of our function by putting f dash x is equal to 0. Then you will get definitely the critical points as C1, C2, C3 and C4. Then you have to take each. Then first one, suppose I am taking x as C1. Then what you have to do is just take points, that is 4 points, slightly less than C1. Look the sign of f dash x. You have to substitute that value in f dash x and look the sign of f dash x. If f dash x is a negative quantity or positive quantity, that you can identify. If f dash x is positive, write f dash x is positive. Just look on the sign of the value. Then just after that take points slightly greater than C1. Then look the sign of f dash x. If it is negative, then here look we took points less than C1 and then greater than C1. Then look the sign of f dash x. F dash x is changing from positive to negative. That means we are arriving at a position like this. For points less than C1, f dash x positive. For points greater than C1, f dash x is negative. Then you can say that C1 is a point of local maxima. C1 is a point of local maxima. And in this case, we can find the local maxima value, by substituting the value C1 in f of x. This is the method. Then coming to the point of local minimum. Look here. And here the tangent at this point is parallel to the x-axis, therefore f dash C2 is also 0. Then look, C2, when we are taking points less than C2, what happens for our graph? The graph decreases, that is f dash x less than 0. When we are taking a point greater than C2, what happens for our graph? It increases, therefore f dash x is greater than 0. Then take x as C2. What happens with C2 is that for points slightly less than C2, f dash x is negative. And for points slightly greater than C2, f dash x is positive. That is, f dash x is changing from negative to positive. In that case, you can say that C2 is a point of local minima. Local minima. And the local minimum value, local minima, we can find by giving C2 in, substituting C2 in f of x. F of C2 will give us the local minimum. This is a method for finding the local maxima and local minima values of a function without the graph. And this test is known as the first derivative test for finding local maxima and local minimum. This is the first derivative test for finding. Look, let f be a function defined on an open interval I. Let f be continuous at a critical point C in I. Then, if f dash x changes sign from positive to negative as x increases through C, that is, if f dash x greater than 0 at every point sufficiently close to and to the left of C, and f dash x less than 0 at every point sufficiently close to and to the right of C, then C is a point of local maxima. Second one, if f dash x changes sign from negative to positive as x increases through C, that is, if f dash x less than 0 at every point sufficiently close to and to the left of C, and f dash x greater than 0 at every point sufficiently close to and to the right of C, then C is a point of local minimum. If f dash x does not change sign as x increases through C, then C is neither a point of local maxima nor a point of local minimum. In fact, such a point is called point of inflection. You have to write this in your notebook. First derivative test. And point of inflection, we have an example here. Look, here, look, the graph is increasing and throughout it is increasing. There is not any change. Therefore, 0 is the point of inflection. It is neither a point of local maximum nor a point of local minimum. The question is, you have to write down this. Using first derivative test, find the local maximum value and local minimum value if they are existing of the following functions. Local maximum value is same as local maxima. Local minimum value, another form of the word is local minimum. And using first derivative test. First question is f of x is equal to x square. Remember, it is the critical point that are giving us the point of the local maximum value and local minimum values of functions. Therefore, the first step is find out the critical points. I repeat, it is the critical points that are giving us the local maxima or local minimum values. Therefore, first step is to find out the critical points. For that, find out f dash x. F dash x is equal to 2x. And for finding the critical point, you have to put f dash x is equal to 0. Implies 2x is equal to 0. Implies x is equal to 0. Therefore, we got the critical point as 0. Then, after this step, our first derivative test is saying that you have to take points slightly less than 0. Then, for points slightly less than 0, f dash x is equal to, for slightly less than 0 means I am taking negative 0.9. You can take any value and always remember, take points very much close to 0. Okay, very much close to 0. Therefore, I am taking in number line. If you are considering the number line, 0 is there, and I am taking minus 0.9. Then it's very much close to 0. And when you are giving that in 2x, you can, what is the answer? It is 2 into, that is, you are getting minus 1.8. It is a negative quantity. And next I am going to take 4 points slightly greater than 0. F dash x is equal to, and greater than 0 means we can take 0.9. It's also very much close to 0 and it is greater than 0. Then when you are giving the value 0.9 to in 2x in f dash x, 2 into 0.9, you are getting 1.8 positive quantity. Then no need to find the value. Actually, want to know whether it is positive or negative. Therefore, here I am changing it as f dash x is negative. Therefore, and here second case it is positive. Therefore, I am going to write like this: f dash x is negative and here f dash x is positive. Now look, our value f dash x is changed from negative to positive as x increases through c. Therefore, first derivative test is saying that if f dash x is changing from negative to positive, then that critical point is a point of local minima. Therefore, x is equal to 0 is a point of local minima. And how can we find the local minimum value? Local minimum value is equal to f of 0. In the function you have to give in the place of x 0. It is 0 square equal to 0. This is the method of answering. Okay, students, next question is f of x is equal to x cube minus 3x. Here also we need to find critical points. For that, find f dash x. It is 3x square minus 3. You can write it as 3 into x square minus 1. For finding critical point, put f dash x is equal to 0. Then you are getting x square minus 1 equal to 0 implies x is equal to plus or minus 1. Therefore, you are getting two critical points. Now, we want to know which is the point of local maxima and which is the point of local minimum. take x is equal to plus 1. For points slightly less than 1, you have to check the sign of f dash x. And slightly less than 1 means you can take any point very much close to 1. I am going to take 0.9. When you are taking 0.9, you have to substitute that value in f dash x. Okay, I am taking the value 0.9, then f dash x becomes 3 into 0.81 minus 1. And it is clear that it is negative. Therefore, f dash x is negative. Next, points slightly greater than 1. Here I am going to take the point x is equal to 1.1. When x is equal to 1.1, f dash x will become 3 into 1.21 minus 1. And we know that it is a positive quantity. That is, f dash x is positive. Now look, here the value of f dash x is changing from negative to positive. Therefore, by first derivative test, x is equal to 1 is a point of local minimum. And the local minimum value is f of 1. Therefore, x is equal to 1 is a point of local minimum and the local minimum value is f of 1. In the function, you have to give 1 for x, then we are getting the minimum value as minus 2. Then consider x is equal to minus 1. Apply the same procedure to this point for points slightly less than minus 1. What is the sign of f dash x? Minus 1.1. Minus 1.1 is less than minus 1. Then f dash x will become 3 into its square is 1.21 minus 1. It is positive. F dash x is positive. For points slightly greater than minus 1, what is the sign of f dash x? Here I am going to take minus 0.9. When we are giving for x minus 0.9, we can easily see that f dash x is negative. Here f dash x is changing from positive to negative. Therefore, x is equal to minus 1 is a point of local maximum. Then we are writing like that. X is equal to, therefore x is equal to minus 1 is a point of local maxima. And the local maximum value is equal to f of minus 1. Then we can see that its value is positive 2. Next, I am going to tell about second derivative test. Second derivative test is also we are using for finding local maxima and local minimum. Here the method is for finding local maxima and local minima using second derivative test is like this. Listen. If you have a function f of x, y is equal to f of x, we need to find f dash x, and by putting it to 0, you will get critical points. Let it be C1 and C2. Next, after this, you have to find f double dash x, that is the second derivative test. It is enough to find, just give C1 and C2 in the second derivative. That is, it is enough to find f double dash C1 and f double dash C2. I am repeating. We have a function y is equal to f of x. You need to find the critical points and the second order derivative. And in the second order derivative, you have to give C1 and C2 as values for x. That is, we need to find f double dash C2 and f double dash C1. Then there are two possibilities. It can be negative or positive. Then suppose f double dash c2 is greater than 0 and f double dash c1 is greater than 0 and f double dash c2 less than 0. If f double dash c1 is greater than 0, then c1 is a point of local minima. Here f double dash c2 is less than 0, then c2 is a point of local maxima. Always we have a tendency to connect positivity with maxima and negativity with minimum. But here in the second derivative test there is a difference. If f double dash c1 is positive, then c1 is a point of local minimum. If f double dash c2 is negative, then c2 is a point of local maximum. We can verify this and by taking the previous problem. F of x is equal to x cube minus 3x. We got x is equal to 1 as a point of local minima and x is equal to minus 1 as a point of local maximum. And we can verify second derivative test by considering the same problem. Look, f of x is equal to x cube minus 3x. What you have to do is find out f dash x, and it is 3x square minus 3. Put f dash x is equal to 0, then you will get x square as 1, x as plus or minus 1. Then here I am going to tell about second derivative test. Therefore, we need to find second derivative. F double dash x is equal to, look, it is 6x. Then what you have to do is find out f double dash 1 and f double dash minus 1. Then I am going to give 1 for x, f double dash 1 is 6 and it is a positive quantity greater than 0. Therefore, x is equal to 1 is a point of local minima. And local minimum value we can find by finding f of 1, just like the previous questions. F double dash minus 1 is, by giving x as minus 1, it is minus 6, less than 0. When second derivative is negative, then that point is a point of local maxima. This is the second derivative test. Therefore, second derivative test is like this. Let f be a function defined on an interval I and c belongs to I. Let f be twice differentiable at c. Then 1. X is equal to c is a point of local maxima if f dash c is equal to 0 and f double dash c less than 0. F dash c is equal to 0 means c is a critical point. And remember, the second derivative at that point should be negative. The value f of c is the local maximum value of f. Second case, x is equal to c is a point of local minima if f dash c is equal to 0 and f double dash c greater than 0. In this case, f of c is local minimum value of f. Remember, this c is a critical point and second derivative at that point is positive. Then only we can find local minimum value. The test fails if f dash c is equal to 0 and f double dash c is equal to 0. In that case, we will go back to first derivative test. You have to write down all this in your notebook. Consider this question. Using second derivative test, find the local minimum value and local maximum value, if any, of the function f of x is equal to 2x cubed minus 3x square minus 12x plus 14. Here we are going to use second derivative test. Anyway, it is the critical point giving us the point of local minima as well as the point of local maxima. Therefore, first we are going to find critical point. Okay, right here, f of x is equal to 2x cubed minus 3x squared minus 12x plus 14. F dash x is equal to 6x squared minus 6x minus 12. That is equal to 6 into x squared minus x minus 2. That is 6 into x minus 2 into x plus 1. For finding critical point, put f dash x is equal to 0. You are getting critical point as 2 and minus 1. In second derivative test, we have to use second derivative. Therefore, f double dash x. And remember, you have to take, it is better to take this form or this form. If you are using this form for finding second derivative test, you have to apply product rule. Therefore, take this one or this one. Okay, I am going to take this one, then differentiating it again with respect to x. 6 into 2x minus 1. F double dash 2 is equal to 6 into 2 into 2 minus 1, and it is given that greater than 0. Therefore, x is equal to 2 is a point of local minimum. And the local minimum value is equal to f of 2. In the function, you can substitute this value and you can verify that it is minus 6. F double dash minus 1 is equal to 6 into 2 into minus 1, it is less than 0. Therefore, x is equal to minus 1 is a point of local maximum. And the local maximum value is equal to f of minus 1. In the function substitute, give for x the value minus 1. And you can verify that its value is 21. Now, we have, using second derivative test, we got the point of local maxima and point of local minimum. Students, our next section is absolute, the concept of absolute minima and absolute maxima of a function defined in a closed interval. If you have a function defined in a closed interval, for that function we can define absolute maxima and absolute minimum, or simply maxima and minimum. Absolute maxima is the greatest value among all the maximum values taken by a function, and absolute minima is the least of all the minimum values. We can define that for a function defined in a closed interval. We know that local maxima or local minima can be absolute maxima or absolute minimum, and that happens at the critical point. And here we have a function y is equal to f of x, which is defined in closed interval a. Then you can find its absolute maxima or absolute minima at the critical points or at the end points of the interval. There is possibility for the maximum or minimum may happen at the end points of the interval also. Therefore, here I am going to tell about the steps for finding absolute maxima and absolute minima of a function defined in a closed interval. The thing is, first you have to find critical points. So by putting f dash x is equal to 0, suppose you are getting the critical points are C1 and C2. Then just find f of C1, f of C2. Just substitute these values in the given function. With this, find out the value of the function at the endpoints of the interval also, f of a and f of b. Then go for a comparison. Which is the least value among these four? That is the absolute minimum value taken by our function. and which is the greatest, that is the absolute maximum taken by our function. Then this is the step for finding absolute maxima and absolute minima of a function defined in a closed interval. Let us see that in your text it is given. Look, step 1, find all critical points of f in the interval. That is, find points x where either f dash x is equal to 0 or f is not differentiable. Step 2, take the n points of the interval. Step 3, at all these points listed in step 1 and 2, calculate the values of f. Step 4, identify the maximum and minimum values of f out of the values calculated in step 3. This maximum value will be the absolute maximum, that is the greatest value of f, and the minimum value will be the absolute minimum value of f. Okay, next we are going to find absolute maximum value and absolute minimum of functions defined in closed interval. Question number 1 is f of x is equal to x cubed minus 12x squared plus 36x plus 18 on closed interval 1, 10. First, and I told you we need to find critical points also. Then for that f dash x, 3x squared minus 24x plus 36 by taking 3 outside, x squared minus 8x plus 12. That is x minus 6 into x minus 2. By putting f dash x is equal to 0, we are getting x as 6 or x as 2. Then what you have to do is just find the value of the function at this critical point and at the endpoints of the interval. And we know that the interval is defined in closed 1, 10. Therefore, you need to find f of 1, f of 2, f of 6 and f of 10. Then by giving the value 1 in the given function, you can see that f of 1 is 43, and by giving 2 in given function you can see that, you can verify that x value is 50, and by giving 6 in the given function it is 18, and by giving 10 you can see that the value is 178. Therefore, the absolute maximum value is 178. Absolute maximum value is equal to 178 at the point x is equal to 10. That's the end point. And absolute minimum is equal to 18, that is at the critical point x is equal to 6. This is the method of finding absolute maximum and absolute minimum. Next question is f of x is equal to 2x cubed minus 24x plus 107 on the interval closed 1, 3. And for finding critical points, we need to find f dash x, 6x squared minus 24. And by giving f dash x is equal to 0, we are getting 6x squared equal to 24, x squared is equal to 4, critical values are x is equal to plus or minus 2. But remember, we can take only those critical values which are belong to our given interval. Only 2 belong to closed level 1, 2. Therefore, we can take only plus 2. Only 2 belongs to closed 1, 3. Therefore, we are taking only that critical point. That's an important thing. We have to take the critical point belong to that given interval only. Then just like the previous problem, what you have to do is you just find f of 2, f of 1 and f of 3. F of 2 is 2 into 2 cube minus 24 into 2 plus 107. You can see that its value is 75. And f of 1 is 2 into 1 cube minus 24 into 1 plus 107. Value is 85. F of 3 is 2 into 3 cube minus 24 into 3 plus 107. It is equal to 89. Therefore, from this, it is clear that least value is at 2, that is 75, and 89 is the maximum value. Therefore, absolute maximum is at 3 and absolute minima is at 75. Students, today we discussed the concept of local maxima, local minima, absolute maxima and absolute minima. Also we discussed about first derivative test and second derivative test. Hope that all the concepts are clear for you. Okay, we'll see in the next class. Thank you. Have a nice day.